Yeah, so we'll continue from where we left off yesterday. So yesterday we looked at how you can make use of your Docker Compose to run multiple containers. Um, so in our case, we looked at a WordPress application, which is a front end, and then we looked at your backend application, which is your database, right? So we looked at that as well, right? So now what we will do is we will look at some of the commands that we can use with your Docker Compose, like how we have your just give me 1 minute here, sorry. So like how with your Docker images and Docker containers, we had commands. With your Docker Compose also, we have commands that we can use. Okay. Now at any point, if you want to execute the YAML file, now in Docker Compose, we call it as your services, right? So whenever you want to start a service, we can make use of your Docker Compose up command. Now, likewise, we have different commands in your Docker Compose. So the first command we have is a Docker Compose config. Now we can use this to validate your YAML file. Now, in my case, I've created this Docker folder, and inside this, I've created the YAML file. Now, if you want to validate this to make sure the syntax and everything is correct, you can make use of this Docker Compose config command. Docker Compose config, and this will simply validate your YAML file. Now, if you get the output like this, okay, whatever you have given in the YAML file, this is simply the script, right? If you get the script as it is, that means your YAML file is correct. Syntax wise, everything is correct and it is working as expected. The next command has a Docker Compose down. Now, at any point, if you want to stop the containers and if you want to, bring down the containers, you can make use of this Docker Compose down. So this is the opposite of your Docker Compose up. So here I can say Docker Compose down, and this will go ahead and stop all the containers that we have created as part of that YAML file. So now you will see here, I don't have those containers running. So the WordPress container, the database container has been removed. Then you have Docker Compose events. Now, if you want to see the events of this in real time, the events of your containers, if you want to see in real time, you can make use of this Docker Compose events command. Now, let me bring this up once again, and then we'll use ampersand. So this will again go ahead and create the containers for us. So here my containers are created, right? Now, if you want to see the events in real time, you can make use of this command. So I can say Docker hyphen compose events, and we can use this JSON flag to specify that we want to see the events in real time. Now, this is as and when you start accessing the container, the events of that will be available over here. So something like, let's say, for example, is my this is what we were using, right? So let me hit this once again, right? So here you can see the events. So like this, if you want to see the events in real time, you can make use of this Docker Compose events instruction. Okay. Then you have this Docker Compose exec. Now, this is same as your Docker exec. So at any point, if you want to connect to any of the containers, so let's say here we have Docker Compose PS, right? So we have two containers running. So this is one and this is the other container. Now, if you want to run any commands, you want to connect to these containers, you can make use of this Docker Compose exec command. So you can either use Docker exec or Docker Compose exec, both are fine. So exec, and then let's say this is the container, and let's say I want to see the processes. So let's say we'll use top command. So, sorry. Okay, 1 minute. I'll have to use this one. Mm, yes, okay, I think it's just database. Yeah. So this is basically the processes that are running. So essentially, if you want to run any of those commands, you can make use of your Docker exec. Then you have Docker Compose help. Now, if you want to see what all instructions that we can run with this particular command, you can make use of this Docker Compose help. So these are all the instructions we have. So build or rebuild the services, config, copy, create, down. So essentially some of the instructions that we're looking at. Okay. Then you have Docker Compose kill. Now, if you want to forcefully kill the containers for some reason, then you can make use of this Docker Compose kill command. So this will go ahead and forcefully kill the containers, and you can see the exit code. Exit code will always be 137 if you are forcefully killing the containers. Then we have Docker Compose logs. Now, if you want to see the logs of the containers that you are running, we can use that. So here I can say Docker Compose logs. Now these are all the logs from the containers. So here you can see this is the WordPress. This is the database. So if you want to see the logs, you can make use of that. Then you have Docker Compose PS. Now this is if you want to list the containers that we are running by making use of the compose. We can make use of it. So I don't have any containers running, so it is giving me an empty output. And then you have the Docker Compose top. Now this is another way. So let's say, so one way is you can use the exec to check the processes. Now you also have a direct command that we can use to do that, which is Docker Compose top. Now what this will do is this will show me the processes for all the containers. So I have two containers. One is the database and then the WordPress. So in this I have the MySQL process running, and in this I have the Apache process running. Right. So basically, if you want to see what all processes that are running, you can make use of this command. So likewise, you have different commands, but these are some of the very commonly used commands we have. Any questions?
Ravi, while checking logs, we need to use Docker Compose logs and we need to give any process ID or anything.
No. So what happens is by default, it will show you the logs for all the containers. So as part of your Docker Compose, whatever containers you're running, so it will show you the logs for all the containers. Now, if you want to see the logs for a particular container, then you will need to give the container name so that it will show you the logs for only that particular container. If
Okay,
not,
Ravi.
by default, it will show you the logs for all the containers that it is running. So here, if you say I have WordPress and I have the database as well. So likewise, we have, I mean, there are a few more examples that you can look at. So here in this repo, have I shared this repo with you guys? Docker?
No, Ravi.
No? Okay. So you should be able to find. So this has enough material for you to get started with this and work with this. So put this here. Yeah, Bharat.
Ravi, I have one doubt. Like,
Yes.
so in this Docker file, like, we had created two containers. So, like, when we use like, Docker compose down or kill, so it will stop both the containers, right? So if I have
Right.
to stop only one individual container, like, how do I do it?
In that case, you'll have to give the name
Okay.
of that
Container,
particular
right?
container. Yes. Not the container ID, but the container name. So in the YAML file, you might have used a name. So in this case, if you say this is the container name, likewise, this is the container name. So you'll have to use that.
Okay.
So likewise, you have more examples over here. So there's another application called Drupal. This also uses a database. Then you have this Redmine. This is another application. This also uses a database. So essentially, it's a front end and a back end concept. Okay, whenever you want to run a front end and a back end together, you can make use of your Docker Compose. Here's another example for running multiple containers. So I have an Ubuntu container running, I have a CentOS running, I have a MySQL running, and then here I have a Jenkins running. So multiple. So whenever we are talking about uh, uh, running multiple containers, we make use of your Docker Compose for that. Okay. The next topic we are going to look at is your Docker networks. Very important. Now, see, we have multiple containers running. We are able to interact with the container. We are able to access the containers, right? How is that possible? Well, that's where Docker networks comes into the picture. So Docker includes support for networking containers through the use of network drivers. So here there are few network drivers that are being used in the backend, which is allowing us to interact with the containers, run the commands on the containers, access the applications, and all those things. Okay, so by default, Docker provides three network drivers for you. So by default, whenever we install Docker, we get three networks by default. Okay, we get the bridge network, we get the host network, and then we get the none network. By default, we get these three networks. So every installation of the Docker engine uh, automatically includes three default networks, and you can list the network by running the following command. So if you want to see what all networks you have, you can run this Docker network ls command, and by default you will have three networks. Okay, so you'll have the bridge network, you'll have the host network, and then you'll have the none network. Now this one was created as part of my Docker Compose. Okay, but by default you'll have three networks. So you'll have the bridge network, you'll have the host network, and then you have the none network. In addition to this, there are two more networks that you can create. So we will talk about that as well. So the network named bridge is a special network. Unless you tell it otherwise, Docker always launches your containers in this network. So this is the default network. So whatever the containers that you are creating, by default, the container runs in this bridge network unless you tell otherwise, unless you tell it explicitly that you want to use a different network. By default, the containers will be running in this bridge network. So let's say we will look at this network. So if you inspect this network, this container, it will clearly tell you which network it is utilizing. So by default, until now, whatever the containers that we have created, these are utilizing your networks, and by default it is running on your bridge network. Okay, all the containers. So bridge network, that's the default network driver. If you don't specify a driver, this is the type of network you're creating. So if you don't tell anything, by default your Docker will be creating the containers in the bridge network. So bridge network are usually used when your applications run in standalone containers that need to communicate. So when do we use the bridge network? Bridge network is used whenever you want two containers to talk to each other, or you want all of your containers to talk to each other. So in our case, we have two containers running over here. We have the WordPress container, and then we also have the MySQL containers. Now, if you see, whatever I'm doing in this container, the data is getting saved over here. Now, for that, there should be a communication between them, right? So how is that happening? This is where your bridge network is doing the work for you. So bridge network allows your communication between the two containers. Okay, and then you have the host network. So for standalone containers, this removes the network isolation between the containers and the Docker host, and uses the host's networking directly. So I'll talk more on this in some time. Then you have the none network. Now, if you don't want to use any networking drivers, you can go with this none network, which disables all the networking for your container. So usually used in conjunction with a custom network driver. So if you don't want to use any of these networks, if you want to use your own custom network, you can disable the Docker provided networks by using this none network. Now, in addition to this, you have two more networks. You have the overlay network, which is mainly used with your multi-system architecture. So until now, we have been working with only one system. But if you want to have multiple systems, that is also possible. And for that, we make use of your overlay network. So overlay network connects multiple Docker daemons together and enables swarm services to communicate with each other daemons. So again, I'll talk more on this in some time. And then you have the MAC-VLAN network. So the MAC-VLAN network allows you to assign a MAC address, which stands for Media Access Control, to a container, making it appear as a physical device on your network. The Docker daemon routes traffic to containers by their MAC address. So all these networks are your virtual network. Now, if you want to force your machine into thinking that it's a physical network, you can go with your MAC-VLAN network. Okay, so these are the 5 networks that we have when we talk about your Docker networks. Any questions with this?
No, Rabbi.
No.
Okay. Let's look at each of these one by one. So first we have the bridge network. So when you run this Docker network ls, that will tell you what all network you have. So Docker network ls. So we have bridge network, we have the host network, and then you have the none network. Now I'll create one container over here. So Docker run -dit. I'm giving it a name. That's the image I'm using, and that's the interpreter. Okay, so Docker run -dit. Let me call this as Alpine 1. The image will be Alpine and the interpreter. So this will create one container for me. Now here, if you see, nowhere I have specified the network. So this is one container. And we create one more container. So we'll simply call this as Alpine 2. So we have two containers, Alpine 1 and then Alpine 2, right? So here I have Alpine 1 and then Alpine 2. Now, both of them by default are using your bridge network. Okay. So if you inspect your bridge network, so Docker network, inspect bridge, right? So here, if you see, this is Alpine 1, and then I should have Alpine 2. So by default, your containers will always run in your bridge network. Okay. Now let's say we will connect your Alpine 1 container. So Docker exec, let's connect to Alpine 1, and we'll use the interpreter hash. Okay, so this is one container. Okay, so Alpine 1 container. Now I'll run this IP-addr show command. So IP-addr show command, this is simply used to show your IP addresses. Okay, so that's the IP addresses I have. So here, if you see this one, 172.17.0.7, that's basically the IP address for this particular container. Now let me connect to now you can check if you're able to connect to the internet or not by using a ping. So ping -c, let's say 5, and I'm telling ping google.com. So your container will also be able to access the internet, right? So how is that possible? Again, your bridge network does that. So you can see I'm doing a ping and I'm getting a response, right? So 5 packets transmitted, 5 packets received, 0% packet loss. So I tried hitting Google 5 times. I got the response 5 times. So that means I'm able to access the internet, right? Now we'll connect to the other container and we'll try pinging Alpine 1 container from the Alpine 2 container, just to see whether we are able to communicate from one container to other container or not. Okay, so in this case, what we will do now is, give me 1 minute. So now let me exit from here and we will connect to Alpine 2. Okay, so this is my second container. So if you want, you can use this IP-addr show, and you can see this is a different IP. So 172.17.0.8, whereas this one was 172.17.0.7, right? Now, if I want to do a ping, so let me try doing a ping, and let's try pinging this address, and you will see here that I'm able to connect. So from this container, from my Alpine 2 container, I'm able to talk to the Alpine 1 container. This is where your bridge network comes in. So if you want these two containers to talk to each other, we make use of your bridge network. Questions?
Ravi.
No, sir.
Okay. Then you have the host network. Now, whenever we, let's say I'll start a new container here, so docker run -dit, and let's do this port mapping called 82:80. Let's say nginx. Okay, so this will start one container for me. So there's my nginx. Let me start one more container, and I'll just change this port number. Let me start one more container, and let me call this as 83. Now, if you see here, I have 3 containers running. Same containers, which is using the same image, but just that they're running on a different port numbers now. Now, this is possible with your bridge network. Okay. Now, let's say you don't want this to happen. You want to use the host machine directly, meaning whenever I'm starting a container, let's say I started on port 80, it should be fixed. I do want to start one more container using that port number. So essentially, if you want to use the host machine directly, you can make use of your host network. So again, here, if you use this Docker network ls, it will show you the host network. Now, let's say I want to use this host network to run my container. So what we will have to do is we will have to explicitly tell when I'm starting the container, I will have to explicitly tell that I want to use the host network. Now, how do we do that? Well, when you're starting your container, okay, you will have to pass that instruction. So here, Docker run, and then you see this --- networks. I'm explicitly telling that I want to use a host network. Now, with this host network, what happens is it will directly use the port number that we have in the image. I don't have to do the port mapping with your host network. Only when you are using the bridge network, you will need to do the port mapping. If you are using the host network, you don't have to do the port mapping. So here, let me try this. So here I'll say docker run -dit, and I'll say that I want to use the host network. Let's give it a name, nginx container, and then the image. Now this will fail for now. Okay, so here if you see, okay, it is running. Now if you see here, nowhere I have done the port mapping, right? I'm not done the port mapping. And if I try hitting that, I will be able to access it. So if I go to, you see I'm able to access this. Nowhere I've done the port mapping, nothing. So what it is doing is it is utilizing the host machines network directly, right? We don't have to do any port mapping or anything. It is now using the host machine directly to start the container for us. For this purpose, we can make use of your host network. Does that make sense?
Yes, Ravi.
So, you can have only one host network. You cannot create a custom host network. Now, the other networks like your bridge network, overlay network, Macmillan network, you can create multiple networks. But the host network, you can have only one. You cannot create more than one. Then you have the overlay network. For now, I'll just tell the concept, but example for this, I'll show you later on. So overlay network is used whenever you want to work with multiple machines. So as of now, I have only one machine. But if you want like multi-machine architecture, like let's say 3 EC2 instances, in that case, we can make use of your overlay network. So I have a separate session for this. So we'll talk more on that later on. The last network you have is the MAC-VLAN network. So like I said, if you want to make use of the MAC address, if you want to force your machine into thinking that it's a physical network and not a virtual network, you can make use of your MAC-VLAN network for that. Now, to begin with this, you don't have the MAC-VLAN network by default, so you need to first create that network, and we can make use of this command. So Docker network create -d, which stands for driver, the driver name, and then if you want to specify the IP address range, you can specify that. So let's create this. So we'll say Docker network create, and I want to create a MAC-VLAN network. We can give a subnet range. So here, let's say 172.16.86.0/24. So that's like your subnet range that I'm giving. And then we can give our gateway. Let's say 172.16.86.1. So one IP address from this range. And then let's tell that this is going to be a parent. So parent is essentially taking this, telling that this is a primary network, and then we are giving it a name. So let's call this as custom MAC-VLAN. So this will go ahead and create a new network driver for us, which in this case will be your MAC-VLAN network. So if you want, you can inspect this to get the details. So Docker network inspect, and here you can see that's the name we gave when this was created. What's the scope, the driver name, what's the subnet we have given, what is the gateway. So all these details you can see, and you can see this is marked as the primary network. Now, once you're done creating that network, you can go ahead and start running the container inside that network, right? So let's say I want to create a new container. So here I'll say docker run -dit, and we will call this as custom MAC-VLAN, and let's call this as Alpine container, the image name and the interpreter. So this will start a new container for me here. And if you inspect this, it will tell you that it is running on the MAC-VLAN network, right? And based on the range that we have given, and the MAC address will be available for you. So that's the IP address. From the range we had given, we have the IP address, that's the gateway, and that's the MAC address. So now we are running this in the custom MAC-VLAN network that we have created, right? Uh, you can also look at the IP address, to see what is the parent network you have. So you can use this Docker exec for that. So we'll say Docker exec Alpine container, and then we will run this IP addr show ETH0. So ETH0 is your primary network. So you can see 172.16.86.2, and that's the subnet range it is utilizing, right? And if you just want, like, if you want to show everything, then you can run this. So this will be your gateway, looping back basically, and then this is the ETH0 that we have defined. Now you can also look at the route, how the IP routing is happening. So I can say IP route, and it is using the gateway 172.16 or 86.1, and this is the source IP address of the container. This is the subnet we have defined, that's the gateway, and that's the IP address of the container. Now, likewise, if you want to create different networks, you can create that. You can run the containers, all that is possible. So essentially, the point of your MAC-VLAN network is to force your machine, your host machine where your Docker is installed, force your machine into thinking that, hey, this is a physical network and it's not a virtual network, and treat this network as a physical network. Questions?
No, Ravi.
No.
Okay. The next thing we have is a Docker events. Now, this is same as a Docker compose events that we discussed. At any point, if you want to see the events in real time, for example, let's say you want to monitor whenever a container is created, you want to see that event, or whenever an image is created, you want to see that event in real time. We can make use of your Docker events. So Docker events gets you real-time events from the server. So these are basically any action that happens as part of your Docker. You can know that, you can capture that information. So following are the options that you can use with Docker events. So you can use filter, you can use format, since, until. So these are some of the options available. Now, to work with this, you will need to have two terminals, because when I run the Docker events over here, my terminal will be logged, because it has to show the events in real time. This will be logged. So I'll be opening one more terminal, and let me connect to this. Now, let's say I'll start a new container. So Docker run -dit, and let's say Alpine. So this created a container. Now the event for this, so this is an action that is happening here. Now this will be captured in my Docker events. So you can see the event as to what exactly happened. So a Docker container was created. It connected to a network. Now which network? You can see the bridge network, and then the container was started using which image? The Alpine image. So that's your events. That's your real-time events. So whenever any of these events happen, any events by default, it will capture that. So that's where we can make use of your Docker events, right? Um, now let's say you want to see the events since this particular date. You can use a since flag. You can also use, since last 10 minutes. So let's say, I'll cancel this, and I want to see all the events um, since the last 10 minutes. So this will show me all the events that has happened. So, maybe let's say you're sharing this with multiple people and you want to know what all has happened. So here you can see we created a container network, right? So you can see here network create, this particular line. So we created a Macquarie network. Then we did an exec. So we executed this command IPADDR show. So, for the last 10 minutes, what all events has happened, it will show that. Likewise, if you want to filter the events, maybe you don't want the events for all the images. You want the events, let's say, so I can use this filter flag, and I'm telling filter it for this Alpine image. So now it will capture the events only when I'm using this Alpine image. If I'm using any other image, it will not capture that. So I'll start an Ubuntu. So a container is created, but it will not capture the events, because now we are filtering it with this one. So only when I start a container with that particular image, it will capture it. So you can do that also. You can also filter it based on the network. You can also use your own format. All those are possible. So essentially, your Docker events is whenever you want to see the events in real time, we can make use of your Docker events for that. Questions?
No, Ravi.
Okay. I'm going to stop here. We have one last topic pending, which is Docker Swarm. So I'll do this tomorrow, and that should complete your Docker. Okay. And I'll also try starting off with your Kubernetes, which is your next containerization tool, right? So we'll discuss about that as well. Okay, so that's all for today. Thank you so much, and I'll see you guys tomorrow then.
Thanks, Ravi.
Thanks, everyone. Bye.
Thank you, sir.
Yeah, bye.